Hello everyone, welcome to another episode of our physics class. So today we'll be taking elasticity. So let me start. Elasticity is the ability of an object to return to its original state when it was deformed. Are you getting me? The ability of an object or its elastic material to return to its original state is what we call elasticity. When you have stretched it or you have expanded it, when it returns to its original state, is what we call elasticity. Now we'll be talking about how stress. Now, stress of an elastic material. What do we call stress? Now, the stress of an elastic material is of the ratio of force to area of an elastic material. The ratio of force is the ratio of force to area in an elastic material. The SI unit of force is what? Newton. The SI unit of area is what? Meter square, or is it centimeter square? Now they can ask you what is the SI unit of stress. Therefore, the SI unit of stress is what? Newton per meter square. Now let's go to strain. Strain. Strain is the ratio of extension. So strain is the ratio. Now let's use E to represent extension and F to represent length. Also this, we can use F to represent force and what? A to represent our area. Now this has no SI unit. Your strain does not have SI unit. This is the reason, because extension can be in meter or centimeter, length can also be in meter or centimeter. So this we cancel this. You have what? No SI unit. So it has no what? It has no unit. So let's also go to young men as our stress over what? Strain. Then we have, what is the formula? That is F over A, that is force over area, then divided by what? Our strain, that is extension over length. Then we go to have force over area divided by extension over length. Then we are going to have division, turn it to times. This one will go up, this one will come down. We go to have force over area times what? Length over extension. Then we are going to have our young modulus now as Fn over what? A. So this is the formula for what? Young modulus. The formula for finding young modulus. Force times length over what? Area times your extension. Now, before we go, we'll also talk about Hooke's law. Now, Hooke's law is very applicable in elasticity. Hooke's law states that provided the extension, the elastic limit of a material is not exceeded, the extension of that elastic material is directly proportional to the applied force. This is what I'm saying. The extension is directly proportional to the force. Also vice versa, your force is directly proportional to the extension. Are you getting me? So your F is equal to what? For this variation to turn to equality sign, this we have a constant. We call this K our force constant, where K is the force constant. So our F equals to KE. Now we can have our K equals to F over E and our. So they can ask you what is the SI unit of our force constant. Now this is it. The SI unit of force is Newton, The SI unit of extension is meter, or you can say meter square. So the SI unit of our first constant, SI unit of the first constant is Newton meter square.
Why is the extension
Sorry,
meter square?
meter.
Okay.
So I will also like if you can find the dimension of your first constant. Find the dimension of your first constant. Now let's move to take the first example. A force of 1.8 Newton extends a wire by 0.4 centimeter. What force will extend the wire by 1.25 centimeter if the elastic limit is not exceeded? Now look at this statement. This statement is relating to Hooke's law. I said it the other time. Hooke's law states that if the elastic limit is not exceeded, what will happen? The extension of the elastic material is directly proportional to the force applied. Now, same thing here. From Hooke's law, let's recall from Hooke's law. Hooke's law, from Hooke's law, we have our F equals to KE, if you remember. So our K equals to F over E. Now looking at it, we are given the first condition that a force of 1.8 Newton extend the wire by 0.4 centimeter. What force will extend the wire by 1.25 centimeter? What they are saying here is that if we are having if we are having two forces and two extension, now this is it. Our K1 is equal to K2. This is what we are going to have. If K1 equals to K2, then our F1 over E1 equals to F2 over E2. Now, the first force given here, let's look at our parameters. That is 1.8 Newton. Our first extension is what? 0.4 centimeter. And our second force is not given. That is what we are finding, right? And our second extension is 1.25 centimeter. Now let's include this our parameter inside this formula and let's see what we are going to get. That is 1.8 over 0.4, right? Newton centimeter. Then we're going to have F2 over our E2 is 1.25. Now, the next thing you do is to cross multiply. The next thing we do is to cross multiply. Now let's cross multiply. Then we have F2 times 0.4 equals to 1.8 times 1.25. What is 1.8 times 1.25? What are we going to have? 2.5. That is 2.25. Now, our F2, then you divide both sides by 0.4. Now, by dividing both sides by 0.4, you are going to have 2.25 over 0.4. Now, we are going to have what? What is 245 divided by 0.4? That is 5.625 Newton. So, therefore, our second force that will extend the wire by 1.25 centimeter is what? The force that will extend it is 5.625 Newton, and which can be approximated as 5.6 Newton. That is all. Now to the next exercise.
I noticed something. This question is looking like a direct variation that as the force is increasing, the extension too is increasing. I guess
Yes, the force increase the extension.
that's like a direct variation.
Example. We are having a force of 40 Newton applied to the end of a wire of length 4 meter and diameter 2.0 millimeter process and extension of 0.25 millimeter. Now, they say we should calculate the stress of the wire. Let's solve solution. The stress of the wire. Now, from the formula for stress, what do you know stress as? Our stress is what? Our stress is known as force over what? Force over area. Now, from the question, we are given our force. Our force F is what? 40 Newton. But our area is not given. which we can find out ourselves. Our area is not given. Now, our area can be found using what? What is the area for a circle? That is pi r square. So area equals to pi r square. Now, we are given diameter. Now, our diameter is what? 2.0 millimeter. Now, you can see this diameter is in millimeter, and our diameter cannot be in millimeter. It should be in what? Meter. So you convert this millimeter to what? Meter. Now, when you are talking about milli means times 10 raised to power minus 3. Let's assume this is the wire. Let's assume this is the wire, and our wire is stretched to form a circle at the end. Now, we are applying what? An extension of what? Our extension is 0.24 millimeter. An extension of 0.24 millimeter. This is the wire. An extension of 0.24 millimeter is applied. So the diameter of this, the diameter from here to here is what? 2.0 millimeter. The diameter of the wire is what? 2.0 millimeter. Now, let's find the radius. Now, the radius will be what? Half of the diameter, right? Because we are needing radius here. Now, our diameter is given as 2.0 millimeter. Now, radius will be what? Diameter divided by what? 2. That is, radius equals to diameter divided by 2, because our radius is half of the diameter. That is 2.0 millimeter divided by 2. So we are going to have what? 1.0 millimeter. You cannot leave your answer in millimeter. You must convert it to what? Meter. You cannot leave your answer in millimeter. You will convert it to meter, because radius cannot be in millimeter. It will always be in what? Meter. Now, let's convert millimeter to meter. Now, milli means what? 10 raised to power minus 3. Our milli means 10 raised to power minus 3. So let's multiply by 10 raised to power minus 3. That is 1.0 times 10 raised to power minus 3 meter. Now our R equals 10 raised to power minus 3 meter. Now let's continue. Our area, which is A, will be what? Pi R squared. Now our R, we have found it here. That is 10 raised to power minus 3, everything squared. And we are going to have 10 raised to power minus 6 pi. Now our pi is given as what? Okay, let me write that first. And we are going to have 10 raised to power minus 6 times. Our pi is given as 3.14. So that is 3.14. Now 10 raised to power minus 6 times 3.14. We are going to have 3.14 times 10 raised to power minus 6 meter square. This is the area. This is our area. Yes. Which is what? Force over area. Now we have gotten our force and our area. Now our stress now will be 40 Newton over 3.14 times 10 raised to power minus 6 meters square. Now, what is 40 divided by 3.14? 40 divided by minus 6 Newton per meter square. Law of indices, if you are having division, it will be minus. So times 10 raised to power minus 6. Then our final answer will be 12.74 times 10 raised to power 6 Newton per meter square. Then you can also finalize it by putting it in sub form as 1.274 times 10 raised to power 7 Newton per meter square.
Standard form.
Second one, we are asked to find strain. The strain is given as, now the formula for strain, we all know that as what? Extension over length. That is our E over the length. Now our extension is what? Our extension is given as 0.24 millimeter, and our length is given as 4 meter. Now you can see that this one is in millimeter, this one is in meter. So we convert this to meter. Our extension is 0.24 times 10 raised to power minus 3 meter. Now putting it there, our strain will be equals to extension over length, which is equal to 0.24 times 10 raised to power minus 3 over our length, that is 4 meter. Your meter, we cancel meter, we have 0.6 times 10 raised power minus 3. That is your strain. Now let's go to our young modulus. Now to find your standard form, we have 6 times 10 raised power minus 4. Young modulus. As we know, our young modulus is the ratio of stress to what? To strain. Ratio of stress to strain. That is our stress over strain. And we have gotten our stress, which is what? 1.274 times 10 raised power 7. And our strain as what? 6 times 10 raised power 4 times minus 4. Now let's solve. We have 1.24 divided by 6. Let's split it. 1.274 divided by 6 times 10 raised power 7 over 10 raised power minus 4. Then we have 1.274 divided by 6. That is 0.213 times 10 raised power 7. Now, law of indices, if you're having minus, to be minus, then minus 4. Then you have 0.213 times 10 raised power 7 plus 4. Then you have 2.13 times 10 raised power. This should be 11. Then with this, you have 10. Now, always note, let me write it very well here. That is 2.13 times 10 raised power 10. Now, always note that your young modulus has no unit. Your young modulus, oh sorry, your young modulus, the unit of young modulus is Newton per meter square. The unit of young modulus is Newton per meter square. This is it. This one, the unit of this is Newton per meter square. Why the unit of this one has no unit. So by the time we divide it, it will be Newton per meter square. So that is all for today. Don't forget.
Don't forget to like and subscribe.